Hello everyone, welcome to Maths IAC. Today we are going to discuss another really important feature of electricity in electric circuits. So especially when you have two resistors connected in parallel and when one of them is significantly larger than the other. Now if you look at these examples, you can see that 5 and 1000, so that is significantly larger than 5. 80 and 2000, 2000 is significantly larger. 10 to the power of 5 is significantly larger compared to 2. So to get the real idea, I want you to pause the video and can you please work out the resistance, the total resistance of each combination using the formula 1 over R total equals 1 over R1 plus 1 over R2, or if you remember the shorter method that I mentioned earlier, you can simply use the product over sum. So you can just multiply the two resistors, 1000 times 5000 divided by 1005, or 2000 times 80 divided by 2080, like that. I explained how to do that and why it works in a previous video. If you haven't watched it, have a look at it again. Either way, pause the video and please work out the total resistance. Okay, here are the answers. If you've done this correctly, you would get 4.98, 76.92 and 1.99 recurring, like so many, I think about 4 nines or something, like that. Now there is a really interesting feature that you can see here. That is, when the smaller resistor is 5 ohms and you have a significantly large one, the total resistance is very close to the size of that. Now look at the other one. 76.92 is pretty close to 80. 1.99 is very close to 2. In fact, the bigger the difference between these two, the bigger the larger the large resistor, the greater this, the closer the total resistance to the smaller resistor. Now this is the relationship that I needed to just show you today, because this is quite important to know. Now the reason, if you think about it mathematically, it makes perfect sense, because so imagine you have two resistors and you're going to find the total resistance. 1 over R total is 1 over R1 and 1 over R2. Now when the size of R2 is very big, imagine this is really large, really big. So you divide 1 by a very big number, this is approximately 0, isn't it? This gets really small. This gets almost close, like for an example here, it's 1 over, in the third example, that would be 1 over 10 to the power of 5, right? So you get 0.4 zeros and a 1. So that's really small, right? So you know, when the last, so in one of when one of them, the value of one of the resistors is very large, the reciprocal of that is nearly 0. So what that means is the total resistance 1 over R total, we can say, is approximately equal to 1 over R, the remaining resistance. So the implication of that is the total resistance is approximately the same as the remaining resistance in this example R1. So that's why the total resistance here is 4.98, which is close to 5 when this is big. Here the total resistance is 1.99 something, which is very close to 2, because this number is very big. So this is an important feature that you can use in your calculations, or for an example, for multiple choice questions. When you see it, it really allows you to get an idea even without doing the calculation.